All right, so this is the very last video for 4.3. So 4.3, we're going to sort of start tying this together with what we did in 4.1 and 4.2. So we're going to give you another purpose besides finding if something's a factor, besides finding if something is a zero, to this whole idea of factoring polynomials. So what we're going to do is we're going to fully factor polynomials. So giving a purpose of more than just doing long division and synthetic division, right? So we're going to use synthetic division and long division to factor polynomials. So there's 3 steps. Step number 1, we're going to use the factor theorem. Now, I haven't told you what the factor theorem is, except that I kind of had. The factor theorem is using either the remainder theorem, long division, or synthetic division to find something with a remainder of 0. So our whole goal is to find some factor that gives us a remainder of 0, whether you do it using the remainder theorem, long division, or synthetic division. Hint to you, you are going to choose possible factors based on factors of the constant, and I'll explain that what I mean when I do an example. Then you're going to use synthetic division or long division, and you're going to divide, and then you're going to factor the resulting polynomial, so you'll have to repeat. Okay, so let's look at this first one. So I want to factor this polynomial function completely. In other words, I want to take it from an x cubed polynomial function to an x times an x squared. And then I'm going to keep that x here, and then I'm going to factor the x squared into its linear factors, an x times an x. Okay, and I'm going to do that through this whole process. So first off, before you start trying to do anything else, double check that you can't do this by grouping. Because if you do the whole process and you could have done it by grouping, you're going to kick yourself. Okay, this one I can't. If I take an x squared out of here, I'm left with x squared plus 2. And there's no way I can turn this into x plus 2. So I can't use factoring by grouping. So I'm stuck with the old, like the whole thing. So job number 1 is to use the factor theorem to find a 0 of this polynomial. Okay, the things that you're going to choose are factors of -6. So your potential zeros are going to be plus or minus 1, 2, 3, or 6. So the numbers that you try out will be factors of the 6. And the reason why is because it's the product of these last 3 constants. Right? So all those 3 together are going to multiply to give you -6. And so you know that your factors are going to be one of these, right? Or 3 of these, I should say. So let's try. So what you do, and unfortunately there's no quick way about this rather than just trying. So I'm going to start with 1. I'm going to plug in 1. So if I plug 1 in for x, I get 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. If I plug that into my calculator, I can see right away it's never going to end up being 0. I actually don't care what it is. As soon as I know it's not 0, I don't go further. The reason I can see it's not 0 is I get -5 and -6, which is -11, and I'm going to be adding 3. So that's never going to be 0. So let's try -1. So now we're going to plug -1 into here. We get -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. Does that equal 0? Well, -1 cubed is -1, plus 2 times -1 squared is plus 2, plus 5 minus 6. Yay, it's 0, which tells me that -1 is my first 0, which means that my first factor is going to be x plus 1. So now you could use long division if you really loved it and you were a glutton for punishment. You could divide x cubed plus 2x squared minus 5x minus 6 by x plus 1 to figure out the quotient, or you can use synthetic division, which most people will. So we're going to take -1 and we're going to divide it into 1, 2, -5, -6. Okay, what's the process? Pull down, multiply, add, multiply, add, multiply, add. Because I got my remainder of 0, I'm good. I knew that -1 was a 0 of my polynomial. I also confirmed that I was right up here. So some people don't use these. Like some people don't use the remainder theorem. They don't go f at 1, f at -1. They just start doing synthetic. They love it, right? So I could have tried 1 with synthetic, and then when my remainder wasn't 0, I reject it. And then I could try -1 in synthetic. And then when I ended up with a remainder, I knew I was good. So now I want to write my quotient. So when I divided x cubed plus 2x squared minus 5x minus 6 by x plus 1, I got x squared plus x minus 6. Okay, so I took out a linear factor and I was now left with a quadratic. Well, you could repeat this process, or you can just factor it. So we know that this factor is still a factor, right? It gets carried down. And then we're just going to factor this guy. So two numbers that multiply to give me -6 and add to give me 1 are +3 and -2. So I've factored the polynomial function. Done. So this is factoring it. The next thing I want to do is solve it. So to solve it, I'm going to find the zeros by letting f of x is equal to 0. So 0 equals x plus 1 times x plus 3 times x minus 2. And then I just say, what makes each of these factors equal to 0? What makes x plus 1 equal to 0 when x equals -1? What makes x plus 3 equal to 0 when x equals -3? What makes x minus 2 equal to 0 when x equals 2? So my zeros, or my solutions, would be -3, -1, and 2. Whew, fun, hey? Okay, last one. Now, just disclaimer, I don't know if you're going to be able to fit all your work onto this little part of the paper. I should have given more space. So if you want to start this on a scrap piece of paper, that might be a good idea, or you can try. So what we're going to do is the same thing. We are going to find the zeros because they want us to sketch the graph. Okay, now before we start doing anything else, to sketch, let's think about the end behavior. So this is my leading term. I have an even degree, and I have a positive coefficient, which means I'm going to start in quadrant what and end in quadrant what. Hopefully you're thinking of a parabola opening up. It's going to start in quadrant 2 and it's going to end in quadrant 1. Now to graph, all I need is the middle bits, right? What are my x-intercepts? So I'm going to factor this polynomial to find my x-intercepts. So first off, I have to find a factor or a 0 of this polynomial. So my options are going to be anything that is a factor of -24. So plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. So these are all possibilities. And again, like I said, there's no shortcut. You gotta just try them. So let's try 1. If I plug 1 into here, I'm gonna get 1 minus 4 minus 7 plus 34 minus 24. Let's check it. 1, I don't think it's gonna work. 1 minus 4 minus 7 plus 34 minus 24. Oh, it worked. I got 0. Did I really? I thought we did it this morning and it didn't. 1 minus 4 minus 7 plus 34 minus 24 is 0. Oh, look at that. Nice and easy. Okay, so we're going to plug in x is 1. So then we do synthetic division. 1. We pull off our coefficients, make sure all the terms are there. So we're going to go 1, -4, -7, 34, and -24. All right. Then we're going to do the process. Pull down, multiply, add, multiply, add, multiply, add, multiply, add. I got my remainder of 0, which means that this polynomial, f of x, is now going to factor to x minus 1, because my 0 was 1, and then my quotient is, because I divide an x4 by an x, it's going to start with x cubed. So I'm going to have 1x cubed minus 3x squared minus 10x plus 24. Now, again, check to see if you can factor this one by grouping. I can't, so all we have to do is repeat the process. So again, I'm trying to find a number that divides evenly into 24 that is a 0 of this. So now I'm just factoring this guy. So I'm going to do f at this time, oh, this is where it was. So 1's not going to work. So it can't be another 1. It can't be -1 because that's never going to add to 24. So let's try 2. I get 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24. And let's plug that into my calculator. So I get 8 minus 3 times 4 minus 20 plus 24. Oh, look at that, 0. It's like I planned this. Okay, so that was the one that gave me 0. So now I'm going to do my synthetic division. So I'm going to divide 2 into, and I'm going to pull off my coefficients. 1, -3, -10, and 24. All right, I'm going to pull down the first term. 1. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. I'm going to multiply. and I'm going to add. I got a remainder of 0. So now my polynomial function has been factored down to x minus 1, which I got from here. And now I have x minus 2, which was my 0 from here. So this gave me my factor of x minus 2. This one gave me my factor of x minus 1. And then I'm left with, I did a cubic function divided by x. So it's going to start with x squared. I've got x squared minus x minus 12. Now I'm left with a quadratic, so I'm comfortable factoring those. You could, like if you hate factoring, you could keep going, right? You could use synthetic division on this, but I'm just going to go x minus 1, x minus 2, and then the two numbers that multiply to give me negative 12 and add to give me negative 1 are x minus 4 and x plus 3. Okay, so that tells me that my zeros are x equals 1, 2, 4, and negative 3. Okay, so this gave me all my x-intercepts. So if I let this equal to 0, right, I could solve for my zeros. Now I'm going to sketch. So I know that this graph is even and it's positive. So I'm going to start in quadrant 2 and end in quadrant 1. I'm going to pass through an x-intercept of negative 3. I'm going to pass through an x-intercept of 1. I'm going to pass through an x-intercept of 2. And I'm going to pass through an x-intercept of 4. Why am I saying pass? Well, if you look back here, every single one of these factors has a multiplicity of 1. Okay, so all of these have a multiplicity of 1, which means I'm going to cross the x-axis at every single x-intercept. So I'm going to start in quadrant 2, and I'm going to cross the x-axis. 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 And look at that, I ended in quadrant 1. Yay, I did it right. Whew. So these are fun. This is like my, I don't know, it's kind of tied as my favorite trig identities in these. I kind of love them both. There's something so satisfying with all of this work on a page and kind of taking something and, you know, whittling it down. So I took a quartic function and I pulled out one linear factor at a time until I ended up with a product of 4 linear factors. And then that gives me my zeros. All right, have fun with this.